Camphor is a waxy, flammable, white or transparent solid with a strong aromatic odor. It is a terpenoid with a chemical formula C10H16O. It is found in Zam-Buk, the wood of the camphor laurel, a large evergreen tree found in Asia, and also of Dryobalanops aromatica, a giant of the Bornean forests. It also occurs in some other related trees in the laurel family, notably Ocotea usambarensis. Dried rosemary leaves, in the mint family, contain up to 20% camphor. It can also be synthetically produced from oil of turpentine. It is used for its scent, as an ingredient in cooking, as an embalming fluid, for medicinal purposes, and in religious ceremonies. A major source of camphor in Asia is camphor basil. Camphor is a camphor derivative with the 3-methyl groups replaced by hydrogen. History: the word camphor derives from the French word camphor, itself from medieval Latin camphora, from Arabic ķēmfər, from Sanskrit, karpara. The term ultimately was derived from Old Malay kappabaris, which means the chalk of Baris. Baris was the name of an ancient port located near modern Saboga city on the western coast of Sumatra Island. This port was initially built prior to the Indian, Batak trade in camphor and spices. Traders from India, East Asia and the Middle East would use the term kappabaris to buy the dried extracted ooze of camphor trees from local Batak tribesmen. In Proto-Malay Austronesian language, it is also known as kappabaris. Even now, the local tribespeople and Indonesians in general refer to naphthalene balls and mothballs as kappabaris. For the local tribespeople, the use of camphor ranges from deodorant, wood finishing veneer, traditional rituals and non-edible preservatives, as the camphor tree itself is natively found in that region. The tree, called camphor in Indonesian, is also known for its resistance to tropical termites. The sublimating capability of camphor gives it several uses. An early international trade in it made camphor widely known throughout Arabia in pre-Islamic times, as it is mentioned in the Quran 76:5 as a flavoring for drinks. By the 13th century, it was used in recipes everywhere in the Muslim world, ranging from main dishes such as tharid and stew to desserts. Already in the 19th century, it was known that with nitric acid, camphor could be oxidized into camphoric acid. Haller and Blank published a semisynthesis of camphor from camphoric acid, which, although demonstrating its structure, would not prove it. The first complete total synthesis for camphoric acid was published by Gustav Comper in 1903. Its starting materials were diethyl oxalate and 3,3-dimethylpentanoic acid, which reacted by Claisen condensation to give dictocamphoric acid. Methylation with methyl iodide and a complicated reduction procedure produced camphoric acid. William Perkin published another synthesis a short time later. Previously, some organic compounds had been synthesized in the laboratory as a proof of concept, but camphor was a scarce natural product with a worldwide demand. Comper realized this and began industrial production of camphor in Tainionkosky, Finland, in 1907. Production: camphor can be produced from alpha pinene, which is abundant in the oils of coniferous trees and can be distilled from turpentine produced as a side product of chemical pulping. With acetic acid as the solvent and with catalysis by a strong acid, alpha-pinene readily rearranges into camphor, which in turn undergoes waxy-Meowane rearrangement into the isobutyl cation, which is captured by acetate to give isobutyl acetate. Hydrolysis into isoborneol followed by oxidation gives racemic camphor. By contrast, camphor occurs naturally as D-camphor, the enantiomer. Biosynthesis: in biosynthesis, camphor is produced from geranyl pyrophosphate, via cyclization of linyl pyrophosphate to bornyl pyrophosphate, followed by hydrolysis to borneol and oxidation to camphor. Reactions: typical camphor reactions are, bromination, oxidation with nitric acid, conversion to isonitrosocamphor. Camphor can also be reduced in isoborneol using sodium borohydride. In 1998, K. Chakrabarti and co-workers from the Indian Association for the Cultivation of Science, Kolkata, prepared diamond-thin film using camphor as the precursor for chemical vapor deposition. In 2007, carbon nanotubes were successfully synthesized using camphor in chemical vapor deposition process. Uses. Modern uses include camphor as a plasticizer for nitrocellulose, as a moth repellent, as an antimicrobial substance, in embalming, and in fireworks. Solid camphor releases fumes that form a rust-preventative coating, and is therefore stored in tool chests to protect tools against rust. Some folk remedies state camphor will deter snakes and other reptiles due to its strong odor. Similarly, camphor is believed to be toxic to insects and is thus sometimes used as a repellent. Camphor crystals are sometimes used to prevent damage to insect collections by other small insects. They are also used as a cough suppressant. Culinary. In ancient and medieval Europe, camphor was used as an ingredient in sweets. It was used in a wide variety of both savory and sweet dishes in medieval Arabic language cookbooks, such as Al-Kitab al-to the first Arabic compiled by Ibn Sayyid al-Warraq in the 10th century, and an anonymous Andalusian cookbook of the 13th century. It also appears in sweet and savory dishes in a book written in the late 15th century for the sultans of Mandu, the Ni'mat-Nama. Currently, camphor is used as a flavoring, mostly for sweets, in Asia. It is widely used in cooking, mainly for dessert dishes, in India where it is known as ๊kæmfər or pakka, and is available in Indian grocery stores where it is labeled as edible camphor. Flavored tablets of camphor are also used as an anti-odor element and kept in clothes used on special occasions and festivals, and also in cupboard corners as a cockroach repellent. Medicinal. Camphor is readily absorbed through the skin and produces a feeling of cooling similar to that of menthol, and acts as slight local anesthetic and antimicrobial substance. There are anti-itch gels and cooling gels with camphor as the active ingredient. Camphor is an active ingredient in vapor steam products, such as Vicks Vapor Rub. Camphor may also be administered orally in small quantities for minor heart symptoms and fatigue. Through much of the 1900s this was sold under the trade name mustard oil. Production ceased in the 1990s. Camphor has been used in ancient Sumatra to treat sprains, swellings, and inflammation. Camphor is a component of paregoric, an opium camphor tincture from the 18th century. Also in the 18th century, camphor was used by Brugger in the treatment of mania. Based on Hahnemann's writings, camphor was also successfully used to treat the 1854 to 1855 cholera epidemics in Naples. Camphor was the original compound used in the development of convulsive therapies for psychiatric illness. It was quite successful, but was supplanted by other chemicals and later electricity as the inducing agent. Herbalism. Camphor is available as a decongestant and as an essential oil for aromatherapy or topical application. Hindu religious ceremonies. Camphor is widely used in Hindu religious ceremonies. Hindus worship a holy flame by burning camphor, which forms an important part of many religious ceremonies. Camphor is used in the Mahashivatri celebrations of Shiva, the Hindu god of destruction and creation. As a natural pitch substance, it burns cool without leaving an ash residue, which symbolizes consciousness. Most temples in southern India have stopped lighting camphor in the main sanctum sanctorum because of the heavy carbon deposits it produces. However, open areas still burn it. In Gujarat, Tamil Nadu, Andhra Pradesh, Karnataka, Kerala and Andamans, camphor is the primary ingredient in any holy rituals. At the end of a holy ritual camphor flame is burned for the deities. In Hindu puja ceremonies, camphor is burned in a ceremonial spoon for performing arti. This type of camphor, the processed white crystalline kind, is also sold at Indian grocery stores. It is not suitable for cooking and is hazardous to health if eaten. Effects on the body. It has effects similar to a muscarinic receptor agonist. Small dose. Its effects on the body include tachycardia, vasodilation in skin, slower breathing, reduced appetite, increased secretions and excretions such as perspiration, diuretic. Therefore camphor must be used carefully and in low dosage in baby oil, where it is used for its calming down effects. Large dose toxicity. Camphor is poisonous in large doses. It produces symptoms of irritability, disorientation, lethargy, muscle spasms, vomiting, abdominal cramps, convulsions, and seizures. Lethal doses in adults are in the range 50–500 mg per kilogram. Generally, 2 grams cause serious toxicity and 4 grams are potentially lethal. Regulation: in 1980, the U.S. Food and Drug Administration set a limit of 11% allowable camphor in consumer products, and totally banned products labeled as camphorated oil, camphor oil, camphor liniment, and camphorated liniment. Since alternative treatments exist, medicinal use of camphor is discouraged by the FDA, except for skin-related uses, such as medicated powders, which contain only small amounts of camphor. See also, 1. 4-dichlorobenzene, citral, eucalyptal, lavender, vaporizer. References. External links: Incham at IPCS, NIOSH Pocket Guide to Chemical Hazards, Camphor at Centers for Disease Control and Prevention.